Happy Monday, year 7. We're going to take a look at how to find factors and multiples and how to analyze them. This is a skill set we learned in school, so let's go over really quickly what we learned a couple months back now. Don't forget that multiples think times tables, so the multiples of 7 are listed here. And that is compared to, say, a factor, where a factor would be the numbers that divide evenly in 2. So first thing I want to take a look at is, from the following list of numbers, identify which of the following are multiples of 5. So what I would do is I would go through with either my highlighter or with my pen, and let's find all of the multiples of 5. So don't forget multiples again, think times table. So let's find out. I know that anything that is a multiple of 5 ends in either a 5 or a 0. Here we go. 5 or 0? Nope, nope, yeah, nope, nope, yep, nope, yep, nope, 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 yes, there's one, no way, yeah, no. So they're all my answers for that one. What I want you to do, can you pause the video and have a go at which numbers you think are multiples of 3? I'll use a different color highlighter. All right, I hope you paused the video and found your numbers. Let me change the color of my highlighter really quickly. Okay, so let's take a look at multiples of 3. Now, what we discussed about multiples of 3 is that when you add the digits of any number, they have to equal a multiple of 3. If they do, happy days, that means that number is divisible by 3. Okay, so let's go through it. So no, 4 plus 4 is 8, and 8 is not a multiple of 3, so that's a no. No. 9 plus 1 is 10. 10 plus 1 is 11, so no. 2, 3, 4, no. 5 plus 2 is 7, so no. 9, 10, 11, nope. We keep striking out. 7, nope, nope. 5 plus 5 is 10, no, no, no. Ooh, I know that 5 plus 1 is 6, which is a multiple of 3. So I found my first one. Nope. 2 plus 1 is 3, so that is a multiple of 3. 9 is 3 times 3, it's a square number. Nope, nope. 8 plus 1 is 9, and 3 times 6 is 18, so there we go. Not many there, but hopefully those are the ones that you found. All right, question number 2. List the multiples. Oh, it says 3, hang on, let me fix that. Okay, list the multiples of 6 between 30 and 50. Let's think. Don't forget times table, multiples, times table. So I'm thinking 6 times 6 is 36. So if it has to be between 30 and 50, let's think that might be not inclusive. So let's start with the first number after 30. So 36 would be the first one. That's 6 times 6. And the next one would be 6 times 7, which is 42. 6 times 8, which is 48. Now notice that when I go to 6 times 9, I should be getting 54, but that's beyond 50. So those are my only solutions. Can you pause the video and give this one a go, please? All right, let's again think exclusive. So not including 20 and 50. If I said inclusive here before, I apologize. I meant exclusive, so we cannot include 30 and we cannot include 50. All right, so here we go. So, oh my goodness, what did I just do? Oh, it got smaller, I'm not sure. Anyway, all right, so list the multiples between, so the first thing, multiples times table, multiples. I know that 9 times 2 is 18, but that's too small. So let's go to 9 times 3. 9 times 3 is 27, so that's the first one. Then 9 times 4 is 36. 9 times 5 is 45. And then notice for the next one, 9 times 6 is 54. That's too big. So hopefully these are the only three. Oh my goodness. Hopefully these are the only three numbers that you wrote down. All right, for this one, identify the lowest common multiple of 7 and 8. So again, multiple, think times table, but this is what we learned in class. Remember, lowest common multiple or least common multiple sometimes is what it's also known for, is described as the LCM. That's the acronym we use to describe that. So first thing I'm going to do is list the times table. So 7, 14, 21, 28, 35, 42, 49. 1, 2, 3, 4, 5, 6, 7. I guess we'll go to 8 since 8's there, right? And 8 times 7 is 56. All right, 8, 16, 24, 32, 40, 48, 56. Oh, look at that. So the first or the lowest multiple they have in common is 56. So that is my LCM. Perfect. Hopefully that rings a bell from what we did in class. Can you please pause the video and attempt this one? All right, let's find out. So we already have the 7s here, so I'm not going to list them, but I'm going to list the 5s. 5, 10, 15, 20, 25, 30, 35. I'm going to stop there because hopefully what you noticed is, I'll pick a different color. 35 would be the LCM for this one. So the LCM between 7 and 5 is 35. Perfect. Okay. Actually, let's skip this one and go to this one. So blue sweets come in packets of 5 and yellow sweets come in packets of 6. A new box of sweets is made using packets of blue and yellow sweets. There must be an equal number of each color in the box. Find the minimum possible number of sweets in this new pack. Ooh, okay. Lots of things to think about here. So it looks like this one comes in packs of 5, but this one comes in packs of 6. We need to make a new box of sweets using both, okay, but there must be an equal number in each box. So what that means is they have to have the same total number. And minimum, doesn't that sound a lot like lowest or least? So this screams LCM. Biggest giveaway is probably that word there. Again, that sounds like least or lowest, which is LCM. So let's list our 5s. 5, 10, 15, 20, 25, 30, 35, 40. And then with our 6s, 6, 12, 18, 24. Oh, look at that. Boom. So the LCM here would be 30. A new box of sweets is made using, there must be an equal number. Okay, so it looks like find the minimum possible number. So the minimum per pack equals 30 sweets. Cool. Can you please pause the video and attempt this question? When you think you have it, can you please go back to Firefly and select the correct answer on my multiple choice question? Good luck.